To this. I echo Jose Adrian's welcome to everyone. My name is Christine Holt-Lewis, and I'm the interim pictorial curator here at Bancroft, as well as the curator of the Reva and David Logan collection of photographic books. I'm very happy to be now part of the roundtable coordinator group here. Today's speaker will be Marissa Friedman, one of our relatively new digital project archivists who started working with us last fall. Marissa came to Bancroft with a range of experience working in cultural heritage institutions and libraries, and most recently at the Labor Archives and Research Center, at the Mill Valley Public Library, and the California Historical Society. Marissa was born and raised here in the Bay Area, and she's particularly interested in community archives and the intersections between digital archives and archival activism. Her diverse background includes working in archives, oral history, working in public libraries and special collections libraries, museum curation, and historic preservation. Marissa received her bachelor's degree in history with honors from the University of Puget Sound, her master's degree in history with an emphasis in public history from UC Riverside, and her master's degree in library and information science from San Jose State. Just before we hear Marissa's talk, I will ask Mary Aileens to give a brief overview of the project and how this fits into our other grants and digital initiatives. Mary's likely very familiar to most of you. She is currently the interim deputy director here at Bancroft, as well as the principal investigator on the grant for the project that we will be discussing today. So without further ado, I will hand the microphone, so to speak, over to Mary. Thank you.
Great, thank you, Christine. And thank you all for being here today. I'm very excited to be here with Marissa, who is going to be sharing information about one of our current grant projects with the National Park Service. This project is very traditional in one way, is that we are digitizing some historic resources in the Bancroft collection. We're going to be preserving them digitally and making them available to researchers. But we're going a little bit further with this project in trying to use some cutting edge technology to extract the data that exists in the forms that we're working with in this particular project. And we're doing this in order to help support an area of emerging research that is computationally enabled, and people are using digital tools and technologies and methods to do their research. And this is in both the humanities, the social sciences, and as well as in the data sciences realm. So this is a new direction we're exploring at Bancroft and through our digital collections. And we're very excited with the work that's been happening on this project. We're using some cutting edge technologies in terms of artificial intelligence and machine learning. And we're learning a great deal through this project. I'm sorry. And there's my dog. So we're trying to make our materials not only accessible for traditional use and traditional research, but also for all these areas of new and emerging research. So it's really an exciting project, and I'm very happy to have Marissa working on it. She's going to fill you in on all the details about what we're doing and what we're learning on this project. So I will turn it over to Marissa.
Thank you. Thank you, Mary, and thank you to Christine and Jose for the invitation to present today. I'm just going to go ahead. Share my screen. All right. Hopefully you can all see that. All right. So again, thank you so much to the Roundtable Committee for inviting me to speak today. It's really exciting to be here to talk about our ongoing project, which is to expand access to World War II incarceree data and using machine learning. So as Mary had mentioned, given the growing interest in the collections as data movement, this project has given us an opportunity to train machine learning models to automatically transcribe information from these digitized records, a process which I will share more about today. So first, I'd like to start a little bit with just a background on the project and the grant program, which supports it. The Japanese American Confinement Sites Program, otherwise referred to as JACS, was established by Congress and administered by the National Park Service. Its goal is to preserve and interpret World War II era Japanese American confinement sites and their history. We've been fortunate at the Bancroft Library to have received 5 of these grants over the past decade or so, totaling about $1.4 million in funding. As we collect heavily in this area and have significant holdings, documenting both the government's actions and activities, as well as the individual histories of those incarcerated. We've been lucky to digitize more than 530,000 items so far, which include photographs, government records, diaries, personal records, and more to date. And then with this project, we'll be adding approximately 210,000 more pages to this archive. All this material is available online at the Japanese American Evacuation and Resettlement Digital Archive, the link there. So if you are curious, please check that out. So I want to start just by highlighting actually this photo, which is from our War Relocation Authority photographs collection here at Bancroft, to give you sort of a visual context for some of the materials I'll be talking about today. This is a photo of Aiko Nishikata assembling paperwork for a fellow inmate's file in the Jerome Office Services section. I think it's an interesting visual demonstration of the sort of bureaucratic information regime the WRA utilized to maintain both intellectual and physical control over incarcerated Japanese Americans. It also illustrates its practice of having incarcerees participate in maintaining these record keeping systems. And the records I'll be describing today were an important part of this effort. So a little bit more about the actual materials. From 1942 to April 1943, the WRA used a census type 2-page form known as Form WRA 26, otherwise called the individual record, to collect a wide range of demographic, educational, occupational, and biographical data about every incarcerated Japanese American. This material was collected soon after their arrival in one of the 10 WRA camps. And these forms collected a huge amount of information, everything from age, birth date, birthplace, skills and hobbies, health and physical defects, physical characteristics like weight and height, language proficiencies, education, backgrounds, occupations and skills, and religion. Importantly, inmates often served as interviewers in all of the incarceration camps, and they also labored in the statistical laboratory at Topaz, which was established by the WRA in November of 1943 to analyze data about the incarcerated population. Under the supervision of WRA statistician Evelyn Rose, data from these Form 26 records was coded by inmates and other WRA office staffers to early computer punch cards, which allowed the information to be processed by early tabulating machines. At the conclusion of the war, a copy of these punch cards and the original handwritten form and typewritten forms from which the punch cards were coded were also deposited at the Bancroft Library, along with many other WRA records. These forms are believed to be the only remaining complete set, totaling over 110,000, organized by camp in existence. So this timeline here illustrates a little bit of the history of this data and what happened with it. In the 1960s, the Form 26 data on the computer punch cards was transferred onto magnetic tape by the Bancroft Library with help from the nascent UC Berkeley Computer Science Department. And then the Office of Redress Administration, or the ORA, acquired a copy of this data from the Bancroft in 1988 to aid in dispersing reparations to former Japanese American incarcerees. Upon completion of the agency's work, the file was transferred to the National Archives. And in 1992, the Japanese American National Museum in LA also acquired a copy of the data file, where it quickly became a popular information resource for former inmates and their families. NARA published this data file it acquired from the WRA, or from the ORA, along with extensive documentation as part of its Access to Archival Databases project back in 2003. So referred to as the Japanese American Internee Data File, it currently serves as an authoritative resource for information for former inmates, their family members, and social science researchers. Margaret Adams, in her 2007 article, Analyzing Archives and Finding Facts, Use and Users of Digital Data Records, provided some more interesting context about this Form 26 data. She notes that initially the WRA managers had used the Form WRA 26 punch card data to learn about and plan for the relocated population. The migration of the records to magnetic tape meant that when the US Department of Justice began implementing the Civil Rights Act of 1988, their staff could directly load them from tape into a network of databases that served as the source for finding and verifying the Act's beneficiaries. 50 years after the creation of the punch cards, their archival preservation in contemporary digital form facilitated research on artists among the evacuees. Copies of the data file have been ordered many times since their transfer to NARA. So this is a really important resource as it currently exists, but as I will explain further now, there are some limitations to this data set, and we're really hoping that this project will sort of fill in those gaps. So as has been noted, this existing data file, the one that's held at NARA, contains gaps, errors, inaccuracies. And I think even more importantly, it does not capture all of the detail, like the texture and the richness, and all of the data fields that are recorded in those original WRA 26 forms. So to better understand some of these limitations, I'd like to just describe a few of the differences that emerge when you compare the data file at NARA with the original forms. So first of all, there are a number of handwritten annotations and corrections on the original forms that it's not clear whether those have been integrated into the data file at NARA. So that's one instance. But there are also many fields that are missing or not fully represented. So we see this as an opportunity to try to recover some of that information. So some examples of fields that are entirely missing from the NARA data file include things like skills, hobbies, educational and employment histories, significant activities. There's an additional information field on the original forms that contain a huge amount of information, anything from extra medical history to educational information, to residential or travel information, extra hobbies. It's sort of a miscellaneous field that captures a lot of data. So none of that has been transferred into the NARA data file. Additionally, one thing you notice here when you look at the occupation information, so what they did when they made the data file at NARA, that data file basically coded, they coded occupations to a set list. So you only see sort of broad generalizations, whereas if you look at the original forms, they often have more different occupational preference fields. And if you look at the employment history, none of that is included in the data file. So what's lacking is really interesting information about salaries and different kinds of employers and different sorts of job duties. And there's a lot of detail there that does not get transferred into the NARA data file. Another example of this is the education field. So educational data is another area where we hope to recover sort of more granular information from the original forms. In the existing data file, only the highest level of education and location of that education, whether it was in the US or Japan, is coded. and all the other details found in the original forms are lost. So things like the exact names and sometimes addresses of educational institutions, dating from grammar school all the way to postgraduate, dates attended, degrees, and other academic specializations or honors. All of those sorts of information are lost in the NARA data set file. So we believe that given that we are digitizing this unique archival resource in terms of having a complete set organized by camp, we have the opportunity here to try to add this back into the data set, hopefully using machine learning. In other words, our goal, I think, is to better capture the richness and complexity of the data provided in the physical records themselves. So how are we going to do this? So we knew going into this project that we would need to add team members that had the technical expertise and experience to help us apply machine learning to these records in order to pull data from them. And actually, Mary was the one who discovered the founding members of what are now known as Doxy AI while they were still graduate students in the Masters in Data Science program at UC Berkeley. We were very impressed by their presentation of their final capstone project, which used machine learning models to automate the transcription of entomological data from images of identification cards for insect specimens. A really interesting project, and we hope that they can apply their skills and experience to our project. And they have, to much success, I think. To give you a sort of basic sense of the process from Doxy's perspective, they've graciously shared this overview of what their project pipeline looks like on their end. And I'll sort of describe it from our perspective. So in the exploratory phase, we work together with Doxy to assess the type of data we want captured in the forms, to identify any unique characteristics of the forms that might require additional logic to be built into the algorithms so that they better handle the images that they'll be presented with. Doxy AI leverages their own proprietary baseline models as a starting point. But I think, as I'll demonstrate in the rest of this presentation, the Form 26 records present some unique challenges that require customization and refinement over time as we move from one set of camp records to a next set of camp records. So Doxy makes targeted interventions in the data understanding phase. So things like resizing and cropping borders from the files that we send them, in preparation for templating the page into different bounded sections for the model to interpret, and then applying advanced measures to help reduce the noise or sort of the extra features that we don't want captured, which usually are caused by imperfections on the page, blurry text, things like that. So each bounded section of the form is then processed through a custom machine learning pipeline. So this includes data cleanup on their end, OCR, or optical character recognition, and error correction. And then the resulting data is returned to us in CSV and JSON formats after they do more post-processing on it. The Doxy team typically runs at least a handful of these batches of TIFF files through the model during the exploration and pilot phases to better customize the baseline model to the images they are processing and to identify any recurring problems before that pipeline is then frozen with remaining batches of files to be fed through on autopilot. So in consultation with the Doxy team, we decided to adopt a targeted approach to develop the machine learning model camp by camp. So after we complete a full set of records from one camp, we debrief to discuss any enhancements that were made to the pipeline and identify any remaining challenges that we hope to address in future sets of Form 26 records from the other WRA camps. This was an approach we decided upon for a number of reasons, not least because there are a variety of often subtle but significant variations in content and form that the records exhibit, both within a single camp and then across all 10 camps. And I will describe some of those in detail now, just to give you a sense for sort of some of the challenges that arose. But I think it's important to note that the idiosyncrasies and the variations that were revealed in the original paper records themselves through the process of applying machine learning models to the collection, I think have been one of the most surprising discoveries for the project team. And I think learning to approach the forms from the vision and perspective of the algorithms has been sort of eye-opening for us here on the project team. So we decided to start the machine learning component of this project with a pilot that was focused on the 17,512 pages of records from the Topaz camp that were previously digitized in an older JAX grant. So to prepare for this, we established a written statement of work that sort of detailed the scope of the pilot. We set targets for accuracy rates on the return data and tried to create a working data model to determine what the expected outputs would be. So the screenshots you see here identified regions on the document to the specified field name and expected value or return from Doxy's processing pipeline. So this was something that we worked together closely on to establish at the beginning. And our goal was to achieve an 80% average accuracy rate, which they measured through what is called a BLEU score. And then for those unfamiliar with that terminology, it was new to myself as well. It simply refers to an algorithm which evaluates the quality of text, which has been translated from one natural language to another. In other words, it's just a score for evaluating how effective the machine translation is. So we learned pretty quickly there were a lot of challenges that the forms presented in terms of having the machine translate effectively. So anything from crossed out, or everything from crossed out text, very light text fonts, lots of handwritten responses and corrections and other marginalia that were written in various styles and by different hands, varying levels of contrast in the typeset, and even the uneven placement of text on the page, where the text was not always aligned, different type settings, and just minuscule differences in placement of text on page. All of those things impact the machine's ability to accurately transcribe text from an image. Additionally, there were a lot of other sort of imperfections, you could say, on the page, things like smudges, tears in the pages, sometimes blurry ink that create a lot of noise, or essentially sort of data we don't want to capture. The machine treats those imperfections like data, but we don't want to capture that usually. Additionally, things like overlapping text. So text that overlaps with lines on the page. So all of those things required sort of manual intervention by Doxy to sort of fine tune their algorithms and fine tune their processing procedures. We also found that there were several fields that we basically had to exempt from those proposed accuracy rates, just due to the fact that they exhibited much more variability and irregularity in placement or alignment of text, or that they had more occurrences of handwritten corrections and crossouts and overlapping text and things like that. So we had to innovate with the pipeline and sort of use a system of marking different return results with a little symbol to help us keep track of the problem fields that the machine was encountering. Ultimately, though, we were satisfied enough with the pilot to proceed to the next camp, which was Manzanar. We learned pretty quickly, though, that many of the assumptions the project team had made about the content and the layout of the forms from Topaz, and this logic was then built into the machine model. Unfortunately, they did not neatly apply to the Form 26 records from Manzanar for a couple of reasons. The project team, or Doxy, actually had to sort of adjust the pipeline and adjust their pre-processing work to reduce even more added noise from blurred ink and the presence of stamps on the Manzanar forms. It sort of overlaid some text. Additionally, a major overhaul of Doxy's page and sort of field cropping logic, so the way they sort of bounded the different data fields. All of that had to be retooled because they found new sorts of tears in the forms and also these really subtle variations in field dimensions and spacing across forms. So I'll jump ahead to show you. On the right over here, you'll see that they've got ahead and sort of gave us this visual. You can see these minute differences in the way that between forms and the way that the placement of the fields and the text, they're slightly off. So all of that impacts the machine's ability to sort of reliably read that text. Additionally, the other major problem we discovered that there are actually several different versions of the original Form 26 documents in use at Manzanar. And these different versions not only contained differences in content. For example, the revised version contained new demographic information about the incarcerated individual's spouse and asked for information about their father's occupation while in the US. So we'll jump ahead and show you here. You can see these green arrows point to the new information, the different information between the forms. There are also differences in spacing of different fields on the page, both front and back between these different versions of the form. So the reason why, again, this is a problem for machine models is because they're finely tuned to identify data points within specifically bounded regions on a page. So basically they had to redo their logic in many ways in the pipeline to sort of accommodate these changes and to make the pipeline a bit more dynamic, realizing that these forms are a lot less straightforward, a lot less uniform than you might expect at a very granular level. So again, this is a lesson for the team that the pipeline would have to be more dynamic. It would have to accommodate both subtle and not so subtle variations, both in height and width and placement of fields. Again, since there may be other versions of the form that we haven't quite discovered yet as we're continuing to process the forms. Despite all of this, though, we have been really pleased with the results we've gotten so far, thanks to Doxy's continuous work to revise and target their improvement efforts. We hit about 85% accuracy scores for the majority of fields the second time around. As you can see here, all the fields in green were the ones that hit our targets. Additionally, Doxy's improved the execution efficiency of their pipeline for this camp so that we can now run up to about 1,800 files a day. So that significantly helped sort of speed up the process. But all in all, I would say the process has been really iterative so far. With each camp, we discover new challenges and limitations of the model, but then we also gain new improvements and refinements to various aspects of the pipeline, thanks to Doxy's work and our collaboration together. And as we begin to work on Poston Form 26 records, we face our biggest challenge yet, training a model to handle the large quantity of handwritten forms that we found in this camp. I should note that using machine learning to transcribe handwriting is much more difficult and has not been as widely successful to date. although there are efforts being made to improve this technology. So we'll see how it goes as we move forward. So, why machine learning? I thought, in order to better understand the value added by this technology and the thorough work of Doxy, I thought it might be useful to compare the results of the basic OCR that we received from our digitization vendor Backstage to the results we received from Doxy. So typically, when we digitize with Backstage, Backstage provides us with preservation TIFF files, PDF files, and then text files for each document that is digitized. So on the screen here, you see this is an example of part of a text from the form of an incarcerated individual from Manzanar. And as you can probably see, there's a lot of noise being picked up by this basic OCR, which is resulting in what appears to be mostly a lot of gibberish. Additionally, the text file itself, like that format of a text file, and the way that the data is delivered in this text file may not be particularly useful in terms of making the data more readily accessible to interested researchers, at least computationally. So with the added benefits of both the baseline machine learning models provided by Doxy and their sort of customized interventions, we receive not only much higher quality content or data in return, but it's also returned in formats like CSV and JSON, which are more readily available and accessible to computational researchers than our existing basic OCR text files would be. So that's just a little bit about, actually here, I'll show you one more thing. So here's an example of what the outputs we received look like from Doxy. So on the top, that's JSON. And for those of you not familiar with JSON, JSON refers to JavaScript object notation. And it's just a popular data interchange format that's both easy for humans to read and write and for computers to parse, hence its popularity. So what we get back from Doxy is JSON in the upper part, and then lower down below, you see the CSV files. And these are considered research-ready formats. So it's much easier, and it's also much easier for us to perform QC and or quality control and analysis of the data using tools like OpenRefine and things like that. So this has been really helpful for us too. So what's next? As you know, as I've noted, the model is not without its limitations. For instance, many of the handwritten annotations and corrections are not easily or likely transcribed by the model. So rather, these marginalia, strike-throughs, and handwritten notes often present as noise for the model. The occupational preference field is one of several fields that continue to be a challenge due to the presence of strike-throughs and other issues. And there's some examples of that down in the bottom left. As Doxy continues to refine the model, we're hoping to explore whether we can automate the detection of these kinds of handwritten corrections and things, and output some sort of symbol that can alert us to the presence of them so we can go back and for future review. Additionally, there's been some issues with representing the structure of data in more complex fields, which contain subfields or fields that have text that cover multiple lines, as illustrated on the right of this slide. So we're working on sort of coming up with ways to fine tune that model even further and get it to read these sections and produce output that more closely matches what's found in the original forms. It's important to reiterate that we are on new ground with this project. So it's been a learning experience for all of us when it comes to setting goals and evaluating results. So in recognition of the subtle variations and complexities of what might normally be assumed to be sort of standard records, We approached the pilot as an opportunity to gauge both the potential efficacy of these techniques, both for the remaining Form 26 records, but also for other large-scale collections of data projects at Bancroft. There was never any intention that the machine learning model alone would provide 100% accurate results. Rather, we saw this as sort of a stepping stone, which could provide a heavy automated lift to undertaking large-scale transcription projects of these enormous digitized collections. And we recognized early on that there would be a need for human review, data cleanup, normalization of the data, et cetera, both throughout the pipeline, and then also once the data is returned to us. So, you know, we've been working on figuring out ways to sort of build towards that and integrate QC and other workflows into that. The project team is now thinking more broadly about what research ready looks like for this specific data set. So some of the questions we've been sort of puzzling over are, you know, what degree of processing on our end is necessary to make the data valuable and accessible for community members and researchers with a variety of backgrounds and levels of expertise. What are the ethical dimensions involved in providing access to this data, which I'll touch on in a minute? You know, what sorts of information is potentially sensitive and should be redacted from the data set? We're already automatically redacting things like social security and alien registration numbers. But obviously, you know, these forms may carry other kinds of personal information that could or should be redacted from, you know, general public access. So these are questions we are thinking through, as we said, about constructing a workflow to better and more ethically manage the data we are collecting. You know, it is also important to recognize that despite what actions we do take now, many future improvements will likely need to be made to the data set over time with input from researchers and users. So moving forward, you know, a key goal for us is to establish a data management workflow that maximizes our ability to fully document any sort of data wrangling work we do once Doxy returns results to us. So to that end, we will be working, I think, with GitHub and building in workflows which fully document all of the work that we continue to do with this data moving forward. So last but not least, I think, you know, this is sort of the crucial point to this project. You know, while these records and the data they hold are not technically legally restricted, or at least not technically restricted in a legal sense, we believe that there may be ethical considerations regarding the unrestricted release of this data and of the digitized forms in their entirety. So to that end, we are working with our community partner and Seattle-based nonprofit Densho, whose mission is to preserve and share history of the World War II incarceration of Japanese Americans, to put together a community advisory group to help us sort of assess, you know, identify potential concerns regarding access to the digitized forms and the resulting data sets, to assess existing strategies for access for both the physical and digital records, and also brainstorm potential solutions for any issues raised. You know, here at Berkeley, we have a variety of means at our disposal, as well as many existing models for how to respond to the concerns and priorities of community members regarding digital access to both the forms and the data set. So there's two different levels that we'll be working on. And, you know, we hope that this process will serve as a model for sort of integrating community input into our future digitization projects and moving forward in alignment with Berkeley's own responsible access workflows. So it's an exciting opportunity to help model this in practice. So I'd just like to, briefly conclude by sort of reiterating the overarching main goals of the project. First, we will be digitizing and creating a preservation copy of the Form 26 records so that they are available to future generations. Second, we hope to reach consensus among community representatives and stakeholders about how best to provide access to the Form 26 material. And then third, we want to provide a new and more complete data set relating to Japanese American inmates during World War II, which improves upon the errors and gaps in the existing data file and creates something new, I think, and hopefully even richer. And finally, this is an opportunity to test and create and implement workflows and tools, which can help us here at Bancroft transform our growing digital archival collections into data that can be made available for computational analysis and enhanced access. Before I conclude, I'd like to note that some of the materials represented here today will be on display in the Bancroft Gallery for our upcoming exhibition, Uprooted, the Incarceration of Japanese Americans, which opens on October 1st. So if you're interested in seeing some of this material, we will have original forms, some IBM punch cards, and some of the magnetic tape files on display. So I'd encourage you to come and visit the exhibition if you have the chance. So yeah, that's it for me today. Thank you for your time, and I look forward to hearing your thoughts and questions.
Thank you, Marissa. That was a wonderful presentation. If we have any questions, or you're welcome to raise your hand. So I think there is one in the chat about the time frame for completion of the project and making this information publicly available.
Yeah, so this grant is scheduled to run through September 2022. In terms of having the information publicly available, Mary, if you want to chime in.
Sure, I can chime in. Yeah, making the material publicly available will completely depend on what we learn from our community advisory group about what is the appropriate way to make it accessible. And that can be anywhere from, completely locked down to, through authentication or some other process to open. So we're going to try and figure that out, once everything's digitized and we have our meeting. Yeah.
And I should note, we'll be meeting with our community advisory group this winter. So that's what that timeline looks like.
Fantastic. Charles, you have a question? Please unmute yourself.
Yes. Am I unmuted now?
Yes.
Good. You said something about an 80% accuracy rate, and I kind of wonder what that means, because 20% inaccurate sounds pretty high to me. In other words, if I was using this information and I knew that 20% of it may be inaccurate, it wouldn't create a lot of confidence in using the information.
Yeah, absolutely. And that's a good point. I think that 80%, I think, is actually a fairly standard, at least by Doxy's estimation that's sort of a standard score or a pretty good score, but they've actually been aiming for higher than that. Like I said, for the last camp for Manzanar that we just did, they hit, I think, almost all but one field had over 85%, closer to 90. But again, as I noted, I think we don't anticipate that this technology will give us 100%. There was never that expectation that it would do that. These forms are simply too, I guess, complex in some ways, or they have too many. The technology is not there to give it 100% yet. So that's why the need for human review is pretty crucial. And we do anticipate that even once we make it available, we will probably be getting feedback from researchers and input on how to sort of improve, because I'm sure they'll keep catching other sorts of errors and things. So certainly it's a work in progress, and I think it will continue to sort of grow and develop. And we definitely will not pretend that it will be 100% accurate when we release this.
Thank you.
Thank you. There's a sort of follow-up to that, Marissa, in the chat. If you found extracting the data through machine learning more beneficial than it is the person transcribing it, has been faster, more accurate, less expensive, those sorts of great things.
That's a very good question. That is something we've talked about as a project team and are potentially exploring. It sounds like we might be exploring hand transcription for some future digital collections. So it's not, that is still an ongoing sort of assessment. I do think that in lieu of, I do think that the machine learning does provide a significant lift. It certainly makes it fast, much faster in some ways. I think than trying to organize even sort of a volunteer run transcription project, things like that. So it might depend too on the kind of collection, the kind of things, if you're trying to transcribe handwritten text, long handwritten text, the machine technology isn't really there for that yet, or it's still sort of developing. And so there you might want to think about, okay, is this worth the time and the cost, and a human effort might be a better way to go there. But I do think things like these records do provide sort of an interesting opportunity because they are seemingly fairly standard, and they don't have long chunks of text. So, that's a good question and sort of an ongoing debate, I think, about.
Well,
and Mary, you might want to.
I'll jump in just because
Yeah.
I'm the money person who
Yeah.
looks at these things. We did look at doing 100% triple keyed data for these, and it was, I don't know, 3 times the cost that this process and would have taken a lot more time probably than this process. And this is something we really did want to explore to see, what can we get out of machine learning and AI, training a model on a set of documents, because we do have a lot of sets of documents that are fairly consistent. What we're finding is Form 26 is not consistent, either in its actual structure of the form itself, but also in the way the data was entered in different camps. So we're learning a lot, but as Marissa said, there are some fields where we're getting 96, 97% accuracy. And those, are kind of, they're critical. Some of them are fairly critical. The ones that are tricky, are things like, these big glommed fields of information about, occupation and that sort of thing. So we're hoping to maybe isolate those fields and have human review of those fields. And so kind of a combination of both machine and human learning for these different areas of the form. But yeah, overall, we couldn't afford $3 a form, which would have, blown our budget to rather large.
Jim Lake asks if this could be, the presentation could be made available. So if Marissa, if you want to share that with us, with the roundtable, Christina and I can find a way to post it somewhere or send an email to all of our participants who are here today, who signed up. We can just, I think there's a way we can just send a follow-up email and get everyone the slides if they want to see it. The other thing too is to answer Jody Matos's question. Yes, it will be. We do have a YouTube channel for the roundtable. So if I think all you have to do is Google Bancroft Roundtable YouTube channel, and it should pop up. So it'll be posted as soon as I can. I don't know if there's any more.
There's another question. Yeah.
From Michael. Will the data pulled through this project be added as metadata, or the digital object only available with the data set? So.
That's a good question. I think typically if we made this, when this goes up on TIND as a digital object, they go up in, I should say the forms are organized by portfolios, and the portfolios have 400 forms and about in each one. So when they go up on Tinned for the access copy, those are 400-page PDFs. So in terms of metadata for that, I don't know yet. We haven't really talked about what that would look like in terms of trying to make, yeah, there's just 400 forms in that digital object. So doing individual metadata like that would be very hard for each form, I think, in the way that we typically make material available. So right now, I think only available within the data set. But Mary, if you have other thoughts on that.
No, yeah, I think the data
Yeah.
set is going to be the primary, delivery of what we're extracting from the forms. They won't be included. It won't be included, but we'll be referenced certainly from the digitized versions of the forms if we make them available openly online. That's the other
Yes.
question.
Yes,
Yeah.
that's to be determined.
To be determined.
But yeah, the data set itself would, I think, would be the primary source.
Fantastic. Oh, there's one more from Kate Pick. Did you look at something like Zooniverse or for crowdsourcing, or were you more focused on trying to try machine learning for this project?
So my colleague Adrian, Sarah, and I have done some exploratory sort of like looking at Zooniverse and other crowdsourcing tools. Like From the Page is another one we looked at. But for this project, we really did. The focus was on implementing machine learning just to see what possibilities.
Yeah, and that was largely due to the form of it, the data form nature of it is it lends itself more to that type of work. But we, are still considering some of those fields again that are low accuracy on the machine learning side, maybe putting those up through a crowdsourcing and then just focusing on those that we have really low accuracy on and having those transcribed instead of entire forms. And we're also going to be looking at crowdsourcing for transcription of handwritten material. So the project that Adrian Sarah is working on is the land case files, which are lengthy legal cases about land claims in early California. And those are all handwritten. Many of them are in Spanish from the 1850s and 60s. So we'll be looking at crowdsourcing for that one as well. So we're looking at all these options of ways to get the data out of the forms, out of the resources that we're digitizing so that they can be used by people doing text analysis, doing computational research in one way or another. And OCR, or optical character recognition, which simply reads the characters on a page, really isn't going to get us there in terms of putting the data into a context that we're looking for.
I believe there's one more comment from Selena Moon on part of the Densho data entry volunteer program. So I don't know if either of you have anything to say about that, or if you know what that.
I'm vaguely familiar with that. I did do some research on like when they compiled. Densho has what they call a names registry, which they've compiled a bunch of different like 10 different data sets from different sets of records. So they have one based on the Form 26 records at NARA. They have other data sets built on another set of records that the WRA used they're called the FAR records. And those were records that they filled out as people left the camps. So it charts like where people went, which the Form 26 records don't have that info. And they've compiled their own database for that. So I've read up on that a bit, and I think they use volunteers for that as well. But that's a good idea. So thank you.
Yeah, and we're also hoping that this data set that we're creating can connect with the NARA data set that it is a kind of a sibling of, and other data sets that Densho's developed. Densho actually was one of the big supporters of this grant when we submitted it, and they've been very active in helping us to recognize and understand some of the things that we hold and how important they are to the history of this event. So we're working on it, working with them closely on this. So yeah, definitely.
And thank you, Christine, for putting up the wonderful upcoming exhibit that you worked so hard on. Yeah, if there aren't any other questions, I would like to end it a little 1 minute early. So
Can I say
Mary,
quickly,
yes,
just I want to say, Marissa's going to have a little section of that exhibit where she's going to be
Mhm.
talking about this project, and so she'll have some more information and examples of this project work there as well.
yes. And that exhibit does open on October 1st, and we will be open for homecoming. So on Saturday, homecoming day, October 2nd, we will be having guided tours of that exhibit. So everyone's welcome as always. So, all right, well, without any other questions or comments, I'd like to thank you all for being here and look forward to seeing you at the next roundtable. And thank you again, Marissa, for this wonderful presentation.
Thank
Bye,
you.
everyone. Take care.
Thank you, everybody.